This is a calculus 2. Now we're gonna discuss integral for rational function. Let's consider two integration. Look at the left side, look at the right side. You can see two integration looks different, but it's exactly same integration. So first, this left side, it's very hard to figure out which method you're going to use. But when you see the second one, so you can do this one is integral 1x plus 1 dx plus integral 1x plus 2 dx. Then this each integrand gonna be ln function. So we're gonna use log property, this addition you're gonna put together. That's how to find this integration right here, guys, right? But left one, this one is very hard to figure it out, how to find the antiderivative, this rational function. That's why we're gonna use partial fraction decomposition, this composition, this section, guys, okay? So I'm gonna write down the rational function. Rational function looks like this one, f of x, p of x over q of x. That's what we call rational function. So when you see this one, what you have to do, this form of rational function, first step you're gonna check the degree of denominator, check degree of p of x. First step is if degree of p of x greater than or equal to q of x, you're gonna do long division. So find the quotient, remainder. Second, this degree is denominator degree is less than numerator. No, you say you find the degree of numerator less than degree of denominator. Then what you have to do, factor q of x. So that's the you take a step to before you start integral of rational function, guys. So I give the specific example for each cases, guys. Make sure you understand which step you're gonna take to the rational function, okay? First case is we're gonna check degree first, guys. So when you see the rational function, you guys have to check the degree. So degree of numerator is 1, degree of top is 1, degree is bottom is gonna be 1. Here is the same degree, so you have to do long division. Long division means numerator is x, denominator x plus 1, x divided by x gonna be 1. So 1 times x, x plus 1 times 1 is 1, subtract. So this is cancel out, negative 1. So this rational function, rewrite the rational function is quotient and remainder. This is quotient. Here is remainder. So we have this quotient is 1. Remainder gonna be negative 1, x plus 1. So after this long division, we can do this integration here. X x plus 1 dx gonna be 1 plus negative 1x plus 1 dx integral 1 dx integral negative 1. I'm gonna put negative in front. Negative 1x plus 1 dx antiderivative 1 is x minus 1 of x plus, that's the ln x, absolute value x plus 1 plus c. That's we have to take it, guys. Remember that. Rational function is to check the degree of numerator denominator. Degree is numerator greater or equal to denominator, degree of denominator. You have to do the long division first. Let's try the B. So I said what? Rational function check the degree. This degree gonna be 3. So degree is largest number in power. Degree gonna be 1. Definitely this is greater than 3 is greater than 1. So what do you have to do? Long division. X cubed plus, there is no x squared, you put the 0, don't forget the 0 plus degree 1 is x, there is no constant, that's the 0. So divide by x minus 1, x cubed divide by x, that's x squared, x cubed minus x squared, subtract, cancel out, 0 minus minus, that's positive, putting it down x. X squared x, that's gonna be x. X times x squared minus x. Subtract, cancel out, x minus minus 2x, bring down the 0. 2x divided by x plus 2, 2x minus 2, subtract, negative, negative, this is cancel out, that's gonna be 2. So now you see, this is quotient, this is remainder. Now, let's do this integration. Integral, quotient, x squared plus x plus 2, remainder, 2 over x minus 1 dx. So you can find this over 3, x squared over 2, that's the 2x, plus this part. So I'm going to write one more time, 2x minus 1, but you can put the 2 is outside. So this one is x cubed over 3, x squared over 2, 2x plus 2, 1 of x minus, antiderivative 1 of x minus is ln absolute value x minus 1 plus c. Previous, the first one is going to be, we check the degree. What do we have to do here? Check the degree, numerator, denominator. Numerator degree is going to be greater or equal to the degree of denominator. You're going to long division first, then you're going to do integration. Now, check the degree numerator, denominator. This time, guys, look at this time. Here is degree is 0. Here is degree is 2. Definitely the bottom gonna be bigger. This case, you don't have to do the long division, but how gonna do this rational function? So first step is, guys, this is a long process, guys. First one is you're gonna factor denominator, okay? Factoring. Okay, then we're gonna partial decomposition of this rational form. So what do you mean by that? 1 over x squared minus 5x plus 6 equal Separate this factor x minus t plus x minus 3. Here is degree 1. Numerator gonna be constant. Numerator gonna be constant because denominator degree 1 numerator less than degree of denominator. If the degree of numerator bigger than degree of denominator, you're gonna do long division again. So basic idea of partial fraction decomposition is check the degrees. Degree 1 here is constant. Degree 1 here is a constant, okay? Now, you understand partial fraction decomposition. Now you have solved this one. So right sides put together. What you have to do, guys, here, you're gonna find A and B. If you find A and B, we can find its derivative. So how gonna find it? Right sides put together, least common denominator, x minus 2, x minus 3. Top gonna be A, x minus 3 plus B. You're gonna compare first one, second one. Compare 2. So this one is x squared minus 5x plus 6 factorial. So this bottom is the same, which meaning is 1. Numerator should be same. A x minus 3 plus b x minus 2. Here is very important concept is you have find the A and B value. A and B value. So there is so many different way. I'm gonna show the very quick, easy way to find A and B. So this equation, you're gonna plug in any x value, but I'm gonna plug in here x equals 3, both sides. Left side is 1, right side x plug in 3. This part is 0. Here is b, 3 minus 2, b times 1, that's the b. So you find the b value is 1. Another way, x plug in the 2, this part, 1 equal a, 2 minus 3, plus 2 minus 2 is 0, b times 0 is 0, this one is 1 equal a, negative 1, a equal negative 1. That's the easy way you find a and b, okay? Now, you find a and b, now this integration is changed. Integral 1x squared minus 5x plus 6 dx gonna be a is negative 1 x minus 2, b gonna be 1 x minus 3 dx. So this first negative integral 1 over x minus 3 dx. So each one negative ln x minus 2 plus ln x minus 3 plus c. So this put together ln a minus ln b gonna be ln a over b. Guys, remember property of log? Now that's gonna be, so this is negative, this is a positive, ln x minus 3 over x minus 2 plus c. That's how to solve this integration. Let's try the second one, guys. So just to slow down, think through each step, then you should work with me, guys. Look at this one. First, you have checked the degree right here. Here is degree 0. Bottom is degree 2. So definitely degree of denominator is bigger. So what you have to do, you factor denominator. Everyone remember how can factor it? So if you're not, I'm going to write down for you. A squared minus B squared is A minus B, A plus B. So here is 1 x squared minus 4 equal, this one is split to this one, x minus 2 plus x plus 2. Here is what is degree denominator, degree 1, always degree of numerator less than 1. That's gonna be A constant, here is gonna be B. Let's find A and B. So how gonna find A and B? Here, just to put this denominator together. Numerator gonna be A x plus 2 plus B x minus 2. So like first one, this one equation, number 2 equation should be same. So you're gonna put same denominator, 1 equal A x plus 2 plus B x minus 2. So I'm gonna plug in x value with x equal negative 2, x equal negative 2 first. When you plug in here, negative 2, 1 equal, this is 0, this term is 0, b negative 2, which meaning is negative 2, b negative 4 equal 1, b gonna be 1 over negative 4, another one, negative 1 over 4. Same thing is you plug in x equal 2, left side is 1 here, a 2 plus 2. When you plug in the 2 there, that's 0. So 1 equals 4a. So a gonna be 1 over 4. You find the a and b. Now you can do the integration. Integral 1 x squared minus 4 dx 1 over 4. So I'm gonna take it out in front of integration 1 x minus 2 dx minus b gonna be negative 1 over 4, 1 over 4 integral 1 x plus 2 dx. Each this rational form you can find the antiderivative 1 over 4 ln x minus 2 minus 1 over 4 ln x plus 2 plus c. So I want to put together, guys, 1 over 4 common factor ln x minus 2 minus ln x plus 2 plus c. How can put together this one? 1 over 4 ln x minus 2 over x plus 2 plus c. That's how to solve this integration. Let's do the case 2. This rational function looks a little different from previous example. So first thing is we have factor out denominator. So x cubed plus 2x squared plus x. So what is common factor? X squared plus 2x plus 1. Now factored x squared plus 2x plus 1, x plus 1, x plus 1. So you're going to put together x plus 1 squared. So previous one is a factor is degree 1 polynomial, but this one is a little different, guys. This is degree 1, here is degree 2, but multiplicity is gonna be 2. This case, you're gonna have different partial fraction decomposition. So how can write this rational function is so partial fraction decomposition is first you write the x, because degree 1 you put the a plus second is you not write down the all x plus 1 square. Partial flux decomposition say you have to do the degree 1 first and degree 2. Okay, after that, make sure here is degree 1, that's the constant on the numerator. Same thing, degree 1 constant. Here is not multiplicity is count, only inside. This is degree 1. That's why you put the constant. So that's you have very careful when you have the factor with double multiplicity, guys, okay? That you have very pay attention with this example, guys. Now, so when you have this partial fraction decomposition, you have least common denominator. So you're going to put together x plus 1 square, then you times here, x plus 1 square, x plus 1 square. Here, x plus 1, x plus 1. Here, x, here you times x. So very careful with polynomial, degree 1 polynomial with double multiplicity, guys, okay? Now, so you're going to put here on the top, a, x plus 1 square, plus b, x plus 1, plus cx. So left side, right side is the same. Now, what should be same here? 5x squared, 20x plus 6, a x plus 1 square plus bx x plus 1 plus cx. So we have to find, guys, you have find a, b, c. How gonna find a, b, c here? Let's find a and b and c. I introduced previous example to plug in the number and find A and B and C. Same thing we're gonna try here. So I'm gonna plug in here. You're gonna plug in any number, but we have to be more efficient. So I'm gonna plug in x equals 0 first, guys. X equals 0. What happened left side? 0, 0, 6. You plug in the zeros, a 0 plus 1 square. Here is a 0, here is a 0. So this one is going to be 6 equal a. 1 square is 1. That's going to be a. So you find the a equals 6. You find the first variable. Now, second is I'm going to plug in x equals negative 1. Can you notice one number you plug in? When you plug in the x equals negative 1, this part is 0, right? X plus 1 equals 0. So you plug in here 5, negative 1 square, 20, negative 1 plus 6. Here is a 0. Here is 0, last one, c times negative 1. That's efficiently you're going to find it. So 5 minus 20 plus 6, that's negative c. Guys, this one is negative 9 is negative c. C gonna be 9. So you only have to find the v value. So you are curious about which number you plug in now. I'm gonna pick the x equal 1 because there is nothing you can make any time it's 0. So I plug in the 1 right here. 5, 1 square, 20 times 1 plus 6, a 1 plus 1 square plus b times 1, 1 plus 1 plus c times 1. So this one is a 5, 26. 1 plus 1 is 2, 2 square is a 4a. C. So you already find A value, C value. You plug in there. This one is 31. This one is 31. 4 times A gonna be 6, 2B, C gonna be 9. So let's solve this one, find the B value. 31, 24 plus 2B plus 9. So this one together, 24 plus 9 is 33 plus 2B. Now you solve that one. Negative 2 equal to B. So B gonna be negative 1. So you find all three A and B and C value right here, guys. Look at this one. Here is A is 6, B is negative 1, C is 9. So partial fraction decomposition, we find the A and B and C. What is A? You find it. A gonna be, we find A value gonna be 6 over x, plus B gonna be negative 1x plus 1, C gonna be 9x plus 1 square. Let's take integral this one. Integral 5x squared plus 20x 6 x cubed plus 2x squared plus x dx. You're going to take this one by one. Integral 6 over x dx plus integral negative 1x plus 1 dx plus integral 9x plus 1 squared dx. So this first one is a 6 integral 1 over x dx negative integral 1x plus 1 dx. Third one is 9 integral 1x plus 1 square dx. What is the first one? 6 ln absolute value x. Second, negative ln x plus 1. Third one is you're going to using substitution method, negative 9, 1 x plus 1 plus c. That's how to find this integration of rational function. Now let's try case 3. Previous two examples, they factor out degree 1 polynomials. So this time, they'll include degree 2 polynomial. So we're going to work on the A part. You guys, the practice B by yourself. Let's try A. This one is every single time when you see rational function, you check it out the degree. This one is degree 1. This is degree 3. So bottom is the denominator, degree of denominator is bigger. So you don't have to do long division. Now, what you have to do, factor out the denominator, x cubed plus x. That's the x squared plus 1, right? So this one is how can do the partial fraction decomposition is x plus 2, x cubed plus x plus x squared plus 1. Degree 1, here is a constant. Degree 2, degree 1 polynomial, bx plus c. That's you're going to write here, guys. So after this, we're going to find a and b and c. Here is going to be, this one is put together. x squared plus 1. Here is a, x squared plus 1 plus bx plus c x. So I'm going to show different way you're going to find a and b and c this time. So left side, right side should be same. So we're going to see x plus 2 equal a, x squared plus 1 plus bx plus c times x. Another way you find a and b and c, you're going to expand the right side. Guys, expand it. So this one is ax squared plus a plus distribute here bx squared plus cx. So you put the same term together, guys. Ax squared, bx squared. So this one is a plus bx squared. Constant term together. Oh no, degree 1 second. That's gonna be plus cx plus constant is a. Compared to left and right side, can you see it? Left side, there's no x squared, so you're gonna see this one is a plus b should be 0. So compared to next one, here is x, here is c times x. So c value should be 1. Now, last one, a, here is constant is 2. So a gonna be 2. So you have a value, c value, you're gonna find the b value. 2 plus b equals 0, b equals negative 2. That's another way you're gonna find a and b and c. So you have choices. The way I'm gonna show you previous example, you're gonna do plug in the x value, find the a and b and c, or you compare the term by term, you find the a and b and c. Now, you find the a and b and c, now you did the partial fraction decomposition. So this one, this integration, now I'm gonna write it integral. Here is a value, guys. A value gonna be find it, b value find it, c value find it. So a value is 2, 2 of x plus b value is negative 2x, c value is 1, x squared plus 1 dx. Okay, guys. Now, what's the next step? Here's very careful, guys. Here, when you see this integration, first part you can do it. 2 integral 1 of x dx. Second part, guys, this one is very careful. Itself, you cannot do any substitution. What you have to do, you're going to separate. This one you have to separate plus integral negative 2x over x squared plus 1 dx plus integral 1x squared plus 1 dx. That you're going to find the antiderivative. So let's do the first one. This one is 2 ln absolute value of x. This one is, guys, this one, how can do that? You're going to use sub. I'm not going to show here, but you can use it here. This one, you're going to be x squared plus 1. Du going to be 2x dx. Then you're going to find this antiderivative. That's going to be, I'm going to find this one, negative 2, negative not 2, guys, negative ln x squared plus 1. And plus, what is antiderivative 1 of x squared plus 1? That's the arctangent. Okay, then you want to put together this one. Here is going to be go up the power. That's the property of log ln x squared minus ln x squared plus 1. I dropped the absolute value because this is a positive. Here is arctangent x plus c. Another way, use a property of log ln x squared over x squared plus 1 plus arctangent x plus c. Let's practice one more time, okay? So this one is, we're gonna do part B, okay? First thing is you have factor denominate. So x cubed plus 4x. What is common factor right there? That's gonna be x squared plus 1. So partial fraction decomposition is 4 over x cubed plus 4x equal x plus x squared plus 1. Here is the degree 1a, degree 2 px, bx plus c. This one is you're gonna put together, guys. Oh no, here is a 4, guys. I'm sorry, here is a 4. So here is take it out x. So put together, guys, x squared plus 4a x squared plus 4 plus x bx plus c. Now, let's compare numerator only. 4 equal a x squared plus 4 plus x bx plus c. Okay, you still can use plug in the number. So I'm gonna do that way this time. So this time I'm gonna plug in x equals 0. X equals 0 plug in 4 equal a 0 plus 4 is 4. 0 times c. So you find a value right away. 4a equal 4, a equal 1. You find it now. Which number you plug in, you don't worry about too much. You plug in any number you want because x equal 1 I'm plugging, 4 equal a. 1 square is 1 plus 4 plus 1 times b plus c. Right, guys? So you're going to plug in the 1 there. So you have 4 equal 5a plus b plus c. So a is 1 right there. You plug in the a equal 1 here. 4 equal 5 plus b plus c. So b plus c gonna be -1. Now, you have to do one more time because you have two unknown variables. So I'm gonna put the x equal -1 this time. X equal -1. You plug in -1 here. 4. A. -1 square is 1 plus 4 plus -1. B times -1, B plus C. Right? So this one is a 4 equal 5a. Negative, negative plus positive, negative, positive, negative C. So a equal 1 again. This one is 4 equal 5 plus b minus c. B minus C equal -1. So you have this one, you find a value, you have this B plus C is -1, B minus C is -1. So let's solve this system of linear equations. So you have B plus C equal -1, B minus C equal -1. You have add together 2B equal -2. B equal -1. Now, B equal -1, you plug in any equation. I plug in the first equation, -1 plus C equal -1, C equals 0. That's you're gonna find it. Everything make sense, this one? So what do you have find it here right there, guys? Now you're gonna find A value is 1, B value is -1, C value is 0. Now we're going to take the integral. Let's find the integral of this rational function. You find the a equal 1, b equal -1, c equal 0. So this one is a equal 1, 1 of x, plus b equal -1, c equal 0. So -1 times x squared plus 4. Right? Let's take integral. Integral 4x cubed plus 4x dx. Integral 1 of x dx. Integral -x squared plus 4 dx. This one is no problem. Let's talking about this one. What do you have to do, guys? This one. So you're gonna using new sub. You're gonna be x squared plus 4. Du gonna be 2x dx. So you have integral. You're gonna see this one negative is put the outside first, guys, here. So this part gonna be integral. X dx is x dx gonna be 1.5 du. So this integral gonna be integral 1.5 du and 1 over u, right? So this one is a 1.5 ln u gonna be 1.5 ln x squared plus 4. That's you're gonna find the second part. Fourth part is not a problem. 1 over x antiderivative ln x minus 1.5 ln x squared plus 4 plus c. I forgot the absolute value. Now, after this, you're going to put together. How can put together? Can you see this 1.5? Go up the power. That's 1.5. So this one is ln after value x minus ln square root x squared plus 4 plus c. Do the one more time using property of log ln after value x over square root x squared plus 4 plus c.